All right, let's talk about something that drives every single data person crazy. Slow queries. You know the feeling. But what if I told you there's a secret weapon, a kind of pre-computed shortcut that can make your reports and dashboards absolutely fly? Well, stick around, because we're about to demystify it.
We've all been there, right? You hit run on a dashboard, you go make a whole pot of coffee, you come back, and that little loading spinner is still just spinning, almost mocking you. Look, this isn't just a small frustration. It's a huge bottleneck for anyone who needs to make fast, smart decisions based on data.
And that waiting, it has a real cost. Every single minute you're staring at that loading bar is a minute you're not finding that key insight. It's burning through expensive computing power, it's delaying important business decisions, and let's be honest, it's just a massive productivity killer.
So, what's the fix? How do we get out of this waiting game? Well, what if instead of forcing the database to run a super complex calculation from scratch every single time, we could just have it look up the answer? That's the entire idea behind this powerful, pre-computed shortcut we're going to dive into right now.
So say hello to the materialized view. Now, you've probably heard of a regular view, which is basically just a saved query, a nickname for a complex bit of code. A materialized view is a whole different beast. It doesn't just store the query, it actually stores the results. Think of it like a physical cache, a special table that holds the pre-calculated answers to your toughest questions, ready to go in an instant.
Okay, let me make this super simple with an analogy. Picture your database as a chef in a busy kitchen. The raw ingredients? Those are your base tables, all your raw data. Now the query that defines the materialized view? That's the chef doing all the boring prep work, the mise en place, ahead of time. All the chopping, dicing, and mixing. The result of that prep work is a container of perfectly pre-chopped veggies. That's your materialized view data. So now, when an order comes in for the final dish, that's your dashboard query, the chef doesn't start from scratch. Nope. They just grab the prepped ingredients and serve up a beautiful dish in seconds.
So this sounds amazing, right? We've got all our ingredients prepped and ready to go. What could possibly go wrong? Well, there is a catch, and it's a pretty big one. We have to talk about how to keep that pre-computed data from going stale.
Exactly. What happens when a new truck delivers fresh ingredients to the kitchen? In other words, when the data in your original tables changes. All of a sudden, those perfectly pre-chopped veggies in the container are out of date. They're stale. And this right here is the central challenge of using materialized views, finding that perfect balance between incredible speed and data freshness.
So how do we solve the stale data problem? Well, you've basically got two main strategies. On one hand, you have the full refresh. This is the brute force method. You just throw out the entire container of old veggies and do all the prep work over again from the very beginning. It's simple for sure, but with massive data sets, it can be super slow and really expensive. But on the other hand, you have the much smarter incremental refresh. This is like a clever chef who only swaps out the specific ingredients that are new or have changed. It's way more efficient, but it can be a bit more complex to set up, and frankly, not all databases or query types can support it.
And that brings us to a really critical best practice, which the Databricks blog points out. If you want to use those super efficient incremental refreshes, you have to be careful about what's in your query. If your view's definition uses a function where the output is unpredictable, something like current date, which changes every day, or random, the database just throws its hands up. It can't figure out what changed, so it's forced to do a full, expensive, start-from-scratch refresh every single time. Okay, so we've got our shortcut, our pre-chopped veggies, we even know how to keep them fresh. But there's still a piece of the puzzle missing. How does the database even know that our shortcut is there? And more importantly, how does it know when it should use it? Think about it. You go and write your query just like you always do, against your big, slow, original tables. You don't even mention the materialized view. And yet, almost like magic, the answer comes back in milliseconds instead of minutes. What is happening behind the scenes?
The answer is this incredible feature called Query Rewrite. This is the database's smart assistant. It's called the optimizer, and it's always working for you in the background. It sees your query come in, it looks at it, and it says, hey, wait a minute, I have a materialized view over here that can answer this exact same question way faster. And then, automatically and completely transparently, it rewrites your query to use that fast shortcut instead. You don't have to lift a finger. It's amazing.
And this is what that magic looks like.
On the before side, you have your long, complicated, maybe 100-line SQL query with a bunch of gnarly joins and aggregations. But behind the scenes, the optimizer transforms it into the after, a dead simple select star from your pre-computed materialized view. The final answer is identical, but the performance is just, well, it's a completely different world.
But how does it decide? This isn't just guesswork. As the Oracle documentation makes really clear, the optimizer is making a smart, cost-based decision. First, it checks, does this materialized view actually have everything I need to answer the user's question? If yes, it then calculates the cost, basically the time and resources, of running the original slow query versus just reading from the materialized view, and it will always choose the cheapest path. This is why it's so critical to have up-to-date statistics on your tables. Those statistics are what the optimizer uses to estimate the costs and make the right call.
Okay, so now that we've got the core ideas down, pre-computation, freshness, and query rewrite, let's zoom out a bit. Because in the real world, not every database handles these things in exactly the same way. The details can be pretty different, and they usually reflect some very different design philosophies. And you can see that play out right here. On one end of the spectrum, you've got a system like Postgres. It's very hands-on. It gives you, the user, explicit control. You have to literally type refresh to update the view. Then in the middle, you have something like Oracle, which gives you tons of powerful automatic options. You can refresh on a schedule, or even every time new data is committed, and it has some of the most advanced query rewrite technology out there. And then at the other end, you have the modern cloud warehouses like Snowflake and BigQuery. Their goal is to make the whole thing feel automatic and serverless. The system just transparently handles the refresh schedules and costs for you.
So you can see that no matter which system you're on, the fundamental problem is always the same. You are constantly trying to find the perfect balance between a few key things that are always pulling in different directions. And this right here is the whole game. This is the core trade-off. It all comes down to balancing three things: query speed, data freshness, and computational cost. You want your queries to be lightning fast? Okay, but you might have to pay a higher cost to refresh the data more often to keep it fresh. Is having up-to-the-second fresh data the absolute top priority? Great, but be ready for the cost and performance hit that comes with it. The perfect strategy isn't a single setting. It's about finding the right balance of these three things for your specific project. Whew! We have covered a lot of ground. So let's bring it all home and wrap up with a few really practical best practices you can take with you and start using right away. Okay, first, go on a hunt for your biggest pains. Those queries that are run all the time and take forever, those are your #1 candidates for materialization. Second, remember to keep your view definitions deterministic, no tricky current date functions, if you want to unlock those efficient incremental refreshes. Third, help your database's optimizer help you. Define constraints and keep your table statistics up to date. And finally, and this might be the most important one, choose a refresh strategy that matches what your business actually needs in terms of freshness, not just what's technically possible.
And that leaves us with one final thought to chew on. As the amount of data we're dealing with just continues to explode, running these huge, complex queries from scratch every time is just getting less and less practical. So I'll leave you with this question. In this new world of massive data, is pre-computing the answers with tools like materialized views no longer just a clever optimization trick, but maybe the new default for how we should be building our data systems from the ground up? Something to think about.